Okay. Okay.
To begin with, I want to let you guys know that my kids are playing in the same room, so you are very likely to hear them. Secondly, we are going to start Chapter 4 by reviewing some power rules which are listed on the PDF entitled R.6. Remember all of those rules of exponents that you learned in Algebra 2. So we'll take a look at this first problem here. 4/9 to the negative 2 power. So what we're really doing when we have a negative exponent like this is we're taking the reciprocal. So this is the same as 9/4 squared. Now anytime you have a fraction raised to a power, what you'll do is you will apply that power to the numerator and to the denominator. So that will be 9 squared divided by 4 squared, which gives us 81/16. Here we've got quite a bit more happening. We've got powers raised to powers. When this happens, what you'll want to do is you'll distribute this -2 to both, but you actually will multiply your two exponents. Anytime you take a power to another power, you multiply. To attack this problem, what I would do, and this only works when you are either multiplying or dividing. If there was a plus or minus in here, this would not work. But I would say, because this -4 is in the denominator, I would move that up to the numerator and raise it to the positive 4th power. Then this has a negative exponent and that has a negative exponent, so I'll put those in the denominator. Squared, and then 4b to the -1 cubed. Now we can start to multiply our power of a power. That means 4 times -1, that gives us 4 to the -4 power. And then 3 times 4 gives us b to the 12th power. Then in the denominator, I have 4 squared, so that just stays 4 squared. And I've got b cubed squared, so 3 times 2 is 6. That gives us b to the 6th. I have 4 to the 3rd power, so we can just write that as times 4 cubed, and then -1 times 3 would be b to the -3 power. From here, I will take anything that I can combine and combine it, and then I will start moving those things with negative exponents to the other part of the fraction. So my numerator will be b to the 12th, and I will take this b to the -3, and I'll move that to the numerator as well, and make that times b cubed. The denominator, this will move down to the denominator. It'll be 4 to the 4th power. I've got here times 4 squared times 4 cubed, and then I've got b to the 6th power. Now we've got a couple more rules of exponents that are coming into play now. Here I'm multiplying two values, same base. I can add these two exponents together. So this becomes b to the 15th power. In the denominator, I've got 4 to the 4th, 4 squared, and 4 to the 3rd. So I can add all of those together as well, and it gives me 4 to the 9th power times b to the 6th power. Because 4 to the 9th power is such a huge number, I kind of just want to leave it as 4 to the 9th. But what I can look at as well is the fact that I've got b to the 15th divided by b to the 6th. When I'm dividing two powers with the same base, I can subtract these exponents. So now what I've got is b to the 9th over 4 to the 9th. And that can be our final answer. We could also, if we wanted to, write this as b over 4 to the 9th power. So now we'll talk about inverse functions. But before we do that, we need to just have a little bit of a refresher about functions in general. A function is anything where you put in a specific number into the domain and you get out a specific number for the range. You cannot put in two domain values and get the same range values for what we call a one-to-one function. So this is still a function, but it is not the special kind that we're looking at called one-to-one. A one-to-one function is one of those functions where every x corresponds to a specific y, just like in a function, but also the reverse has to be true. Every y refers to a specific x. So this bottom one is one-to-one, whereas this top one is not. Here we're asked to take a look at a few different functions and see whether or not it's one-to-one. One way to do that is to just pick a value for y and solve the function. So on this first one, I might let f of x be equal to 4. So this is 4 is equal to negative 3x plus 7. When I solve this, only one value comes out. I know it's a function because it's listed as a function, but because I didn't get something like plus or minus, I know that this is only a one-to-one function. Another way that you can think about this is to plug in some values. So for example, take a look at this next one. So on this one, what I'm going to do is I'm going to first let x equal 7. Why did I pick 7? Well, because it's going to be something that I can deal with. So if x is equal to 7, f of x is equal to 0. What if I let x equal negative 7? F of x is also equal to 0. So here I've input two different x values and gotten the same y value for it. That means that this is not a one-to-one function. Another thing to do is to sketch the graph and look at the graph. We have something called the horizontal line test. You guys remember the vertical line test from when we were checking for functions. Well, when we're looking for one-to-one, we're looking at a horizontal line test. Now you might be thinking, oh yeah, right there it fails the test, but it actually doesn't. Because remember, this is tangent at the x-axis, but it also intersects. So here we actually do have a one-to-one function. Taking a look at the other one, this is not a one-to-one function. This information will actually tell you whether or not a function is one-to-one, and I did each one of these. First, pick a y value and solve for x. If you only get one answer, the function is one-to-one. The next thing you can do is see if you can plug in any two x values and get the same y value. If that happens, then you got not a one-to-one graph. Here we sketch the graph and we use the horizontal line test. If it crosses the horizontal line in more than one place, it's not one-to-one. The last one actually would have been applicable to that cubic function we looked at. If the function is either increasing or decreasing over the entire domain, meaning that there are no turning points, then you have a one-to-one function. Now sometimes we're actually given two functions, and we want to know, is one of these functions the inverse of the other function? And the way that we actually find that out is to calculate f of g, and we calculate g of f. And what we're looking for is we're looking for the same answer in both cases. So to calculate f of g of x, sometimes we write it like this. Do you remember that? What that means is that I'm going to put g of x, so this whole thing, in place of x right here. So that gives me 2 times 1/2 x minus 5 plus 5. That's x minus 10 plus 5, and this is x minus 5. Now I have to do g of f of x. So now I'll start with 1/2 x times 2x plus 5 minus 5. So I get x plus 5/2 minus 5. And for this I get x minus 5/2. So here what we see, because these values are not the same, that no, g is not the inverse. On the next two problems, we are given a list of coordinates. These are each functions. So when we start looking at the inverse of f here, we write it like this. And the cool thing about it is you switch your x and y values. Taking a look at function g, one thing that maybe you haven't noticed, but you would probably notice it if you started to write this out. Please, Andrew, is what my daughter's saying, in case you're curious. This is not a one-to-one function, because what we see happening is here we can put in a -1 and get a 2, or we can put in a +1 and get a 2. Also, if we enter a -2, we get 5, but if we enter +2, we also get 5. So this is not one-to-one.